This is part 6 of section 4.3. We're now going to begin talking about identities. These are some relationships that are always true. You need to memorize these identities, and in the next chapter, we're going to be getting more. There are certain ones that you need to have absolutely memorized in order to be successful in calculus. And there are some that are useful that I will not make you memorize. So make sure you're paying attention to that before the exam. You want to make sure that you memorize what you need to. Okay, so we've already talked about several of these. We've talked about the reciprocal identities. Now this is just spelled out where sine and cosecant go together, cosine and secant, and and it works both ways. So the sine and cosecant are reciprocals, but if you start off with cosecant, you can put sine in the bottom. You've talked about these. And also, we may have not written it exactly like this, but we know that sine and cosine come from our x and y values, and we know that tangent and cotangent also come from our x and y values. So we just put in the associated sine or cosine. These are quotient identities. Now let's talk about the Pythagorean identities. These are all based on what we've done with a right triangle. Remember, we had a squared plus b squared equals c squared. And when we have the unit circle, our hypotenuse of our right triangle was always 1. This was always our x value. This was always our y value. Okay? So basically, when you're talking about a unit circle, if we're making a triangle out of it, we have x squared plus y squared is equal to 1. It's very overlapping, okay? So if we take what we know about sine and cosine, we know that if we are on the unit circle, our sine value is our y, and our cosine value is our x. If we just simply substitute that in here, we get cosine of t squared, because that's our x value, plus sine of t squared equal to 1. And then, as I've mentioned earlier, we don't normally write powers of sine function or of trig functions this way. We normally write the 2 on the function and have the argument of the function separate. Okay? So what we've done right here, just plugging in what we know about x and y, we developed this first identity. Okay? Now, if I want to get this one, all I have to do is divide all of these by cosine squared. So if I do, I would have cosine squared of t plus sine squared of t is equal to 1 if I divide everything by cosine squared of t. And then use what we've done before. Well, here I'm dividing it by itself, so that's definitely a 1. We know that sine over cosine is tangent, so this is tangent squared of t. And we know 1 over cosine is secant. So this is secant squared of t. And you can see you've got your second identity here. Now, if you want this one, you are going to divide everything by sine squared instead. But that's where these things come from. Yes, you need to memorize them, but if you understand where they come from, it's going to be that much easier. Okay, so let's work a few problems with this information. We are given cosine and tangent values, and they want us to find the sine value. So what I'm going to do is I'm going to look for an identity that has a sine and a cosine and a tangent in it so that I can make those adjustments. So if I look right here at the quotient identity, I have sine, cosine, and tangent all together. I know that tangent of t is equal to sine of t divided by cosine of t. Now, if I want to make this a little bit easier on myself, I can multiply both sides by cosine t, and I'll end up with sine of t is equal to tangent of t times cosine of t. So sine of t is equal to my tangent value, negative square root of 21 over 2, times my cosine value, which is negative 2/5. So my sine value is going to be positive. The 2's cancel, square root of 21 over 5. Okay. Now, if we are given that our sine value is negative 2/5 and our cosine value is the square root of 21 over 5, we want to find cosecant, secant, tangent, and cotangent. Okay, so let's do the reciprocals of these first because that's going to be the easiest. So if I've got sine, then its reciprocal function is cosecant. And that means I just take the reciprocal of this one. So it will be negative 5 over 2. Okay. Now the reciprocal function for cosine is secant of t. So this will be 5 over the square root of 21. And once you rationalize that by multiplying top and bottom by the square root of 21, you get 5 square root 21 over 21. Okay. Now we know that tangent is sine divided by cosine. So tangent of t is sine, negative 2/5, divided by cosine, square root 21 over 5. So this is equal to negative 2/5 times 5 over the square root of 21 to give us negative 2 over the square root of 21. And then if you rationalize that by multiplying top and bottom by the square root of 21, you get negative 2 square root 21 over 21. And then for cotangent, you can either figure out cosine divided by sine, or you can find the reciprocal of your tangent, and I'm going here before we rationalize, and that's going to give me the square root of 21 over 2 negative. Okay, now let's work these problems. We're going to use our fundamental identities to find the exact value of each expression. Okay, so here I have tangent of 65 degrees times cotangent of 65 degrees. What I'm going to do is I'm going to use, you have a couple of options here. Let's first use our reciprocal. What I have here will be tangent of 65 degrees times 1 over tangent of 65 degrees, because cotangent is the reciprocal of this. And then you would have a cancellation, and you would simply get 1. Okay, so that's one option. I also could have changed these into sine and cosine, and I would have had sine of 65 degrees over cosine of 65 degrees times, this is cosine over sine, either way, everything cancels out and you get a 1. Okay? Now let's look here. Cosecant squared of 32 degrees minus cotangent squared of 32 degrees. Okay? So I can write these as reciprocals. I can change these so that they are in terms of sine and cosine. But if I see some squares, I'm going to look at my Pythagorean identities to see if there is one of these that shows a relationship between the two squares that I have. Here I have cosecant and cotangent, and this identity right here has cosecant and cotangent. Okay, so I'm going to possibly use this identity right here. Okay, I notice that these two angle values are the same. So I have that here with the t values. I can make a cosecant squared minus a cotangent squared by just subtracting the cotangent over to here. So this identity is the same as this one. I've just rearranged it. I have this exact pattern right here. I have cosecant squared of an angle minus cotangent squared of the same angle, so it equals 1.